right. Hello, everyone. Welcome to Making Games with Oculus. I am Chris Jurney. I'm a developer relations engineer at Oculus. Generally, the talk is going to be about both making games technically, like how do you go about making them, and also with both the devices and also with the company. So I'll tell you a little bit about myself. I'm originally from Atlanta. I went to school in Georgia Tech and worked here for a few years before moving away to make a bunch of video games. I worked at Relic, Chaos, Double Fine, and now Oculus. So this is what we're going to be talking about. So I'm going to go over sort of the state of Oculus VR, like where we are in our various product life cycles and how that's relevant to you as a game developer. I'm going to talk about the Oculus publishing group that I'm a part of and how that might be relevant to you. We're going to go through the VR design challenges you're going to face when you try and make content for VR. And then I'm going to do a really quick Unity tutorial. If you haven't made a VR app yet, I'm going to show you how easy it is. You can do it in about 3 minutes. Okay, so let's talk about Oculus VR and where it is. So why is Oculus relevant to game developers right now? Well, the answer is we have 3 products launching in the next year. The first of them is going to come out next month. It's called the Samsung Gear VR. It's a partnership between Samsung and Oculus. It uses any of the Samsung flagship phones, the S6, S6 Edge, S6 Edge Plus, or Note 5, and you slot your phone into it. It's a $99 device, and it uses your phone screen, running at, all these phones are 2560 by 1440 screens, running at 60 hertz with a fancy low persistence mode. And it gets you VR. You have orientation tracking, you have a really nice screen, and a nice wide field of view. The device supports Bluetooth gamepads. It's got a fancy new form factor. If you've used the Innovator Edition, it eliminates the top strap. It's got a fan in there. It's also got a built-in touchpad and microphone. The touchpad's on the side. So that's our mobile product. It's like a, inexpensive consumer device launching next month. Next up, in the first quarter, we have the Oculus Rift. So this is our PC-attached headset. It's a little bit fancier. It's got positional tracking and 360-degree head tracking by sensors on the back of the head. It's got 2 screens in it. They're 1080 by 1200 each, and they're running at 90 frames a second. It's also got an integrated microphone and integrated headphones. So included in that box, you're going to get the headset, you're going to get the Oculus sensor, and an Xbox game controller, which is super important to you as a game developer because you know that everyone's got a specific input device that you can target. And our third product that is relevant to you as a game developer is Oculus Touch. So this comes out after the headset in the second quarter of 2016, and it's a tracked controller that gives you hand presence in VR, so you can see your hands. It's wireless. It knows what pose your hand is in, so you can point at stuff. You can give a thumbs up. It's got haptics in there, so it can vibrate, give you some feedback on when you're coming in contact with virtual objects. The design of the device is centered around giving you hand presence. It's not to be, a controller that you hold in VR. It's to give you your own hands in VR, and the feeling that the hands that you see in VR are your own hands. So here's what some of that looks like in an experience we built called Toy Box. Is this video going to play? Yes. So this is 2 people in VR, playing with stuff with their hands. Because of the integrated microphone, it's also got voice chat while you play that. All right, so that's Oculus Touch. So those are the platforms as a game developer you can start targeting now to potentially hit the release window for. All right, so those are the devices. Now let's talk about software. So Oculus puts out a bunch of software. Most important to game developers are the SDKs. So there's a Gear VR SDK that lets you target real-time rendering on the Gear VR. There's the Rift SDK, which is the PC SDK to get your frames onto the device. It also includes the data for tracking the position and the headset so you can know where the headset is. And it also includes the touch data, so what position the user's hand is in and where their hands are in space. And then we have an audio SDK that does really high quality sound spatialization. So that means if you play a sound and then you put it through our audio SDK, then the user will be able to tell exactly where it is in space, including incorporating the head tracking. So it gives you better immersion in VR. And that's free. You can ship that across all platforms, in VR, out of VR, other people's VR headsets, whatever you want to do with it. And it works on both the Rift and Gear. We also ship a number of engine integrations, both for Unity and Unreal, to make it easier for you to work. So beyond those SDKs, we also have the Oculus platform. So we're going to ship a full suite of game and app services that work across both Gear VR and Rift. It includes all the stuff you'd expect from a platform to help you build and sell online games. So that includes concept of an identity. The users will have an Oculus ID. It's separate from your Facebook ID, in case you were concerned. So they'll have cloud saves, achievements, leaderboards, in-app purchases. You'll have a friends list. You'll have a social graph. You'll be able to do matchmaking and peer-to-peer networking with reflections, so you don't have to solve your own firewall penetration issues. If you've ever worked on a multiplayer game, that can be frustrating and hostile. There will be a build framework, so you will have control over your own patches. So when you want to release a new version of your game, you don't have to talk to us. You can push it out. It'll also have build management, so if you want to run a beta for your users, you can do that and run different versions for different users. And we will also give you keys, so you can both give away keys through our store, and if you sell your game in another store, we will provide you keys for free to sell on other stores. So that a lot of those features will roll out with the Gear VR, and the rest will start rolling out early next year. So the store, if you make a game, you probably want to sell it. So we have a store. This is what it looks like for the Gear VR. It's a ground-up experience designed for VR, so it's in 3D, it's wrapped around you. It works well with the respective devices. There's no launcher, you just put it on. So on the Gear VR, you slot your phone in and put it on your face, and you're in your library, and the store is right there with it. And then when you launch a game, you go into it, you play it, you exit, you come back to this as your sort of home experience. It works on the PC as well. This is early mock-up of the PC store. And the same experience happens there. So the headset's plugged into your PC. You don't really have to worry about clicking on anything. You just pick up the headset, put it on, and you're in the home launcher. And you can play games or buy games. So the store is curated. It's curated by the publishing team, which I'm a part. So we want to make sure that users have really good, high-quality content to see and buy. And that's good news for developers making high-quality games, because it won't be flooded with cheap, crappy apps. We work with you on getting your games out. So when you have a game that you think is ready to start a conversation with a store, you email me or email submissions at Oculus, and we'll start the conversation, and then we'll help you with pricing and dates and when you want to go on sale and all that sort of thing. The store is also available via the web and a mobile app. So if you're not in VR and you decide you want to buy a game, you can do it there too. So all this stuff is managed by a group called Oculus Publishing. So I'll talk a little bit about that. Oculus Publishing is generally broken down into 3 groups. The first looks a lot like a traditional publisher. It's developer relations. So they talk to developers about access to prototype hardware and publishing deals and that sort of thing. There's partner engineering, of which I'm a part, and that's a group of really experienced engineers that have shipped a bunch of video games that work with external game teams to make good VR. So we help you with performance and debugging. If you've got any issues with the SDK or any of our technology, we can help you work them out. I just did the math last night, and the sun actually never sets on the partner engineering team. There are engineers spread just enough around the world, US, UK, Japan, and Korea, that you can always find an awake partner engineer somewhere in the world. And then there's a store team that manages the content that goes up in the store and the process of QA and testing to make sure the games are ready to go in the store. And generally, the way we think about this whole team is that our goal is to make sure that people that make games for the Oculus are successful. So this team is only successful if you are. We measure our success with metrics based on how successful game developers are. All right, so that's sort of the context for what's coming in VR and why you might be interested in it. So if you've already decided to work on it, there are some challenges you're going to face because VR is not the same as traditional video games. So just to give a broad overview, designing for VR is different. So if you're not super familiar with VR, and not many people are yet, I recommend you read our best practices. So we write a lot on our site. We have a best practices document that's updated constantly as we learn stuff. And we write about it often in our blog, our developer blog. And the list of best practices is basically stuff we've learned that works well in VR, because there's some stuff that just doesn't work well and will make your users uncomfortable and will make for a bad experience. So the best practices are not laws. No one knows everything about VR because even though VR has been around a long time, people have not been trying to make large numbers of games and large numbers of consumer-friendly experiences in it. So there's a lot to learn, and the best practices are a good baseline. If you do all those things, you will be able to make a comfortable experience in VR. And then beyond that, there's a lot of experimentation to do and learn. When you're doing that experimentation, remember that comfort is super important and should be the #1 thing on your mind. Because if people throw up when they play your video game, they're not going to play it very many times. It's definitely possible to make comfortable experiences. It's also possible to make people really ill. If you get the eye transforms wrong and put one eye slightly off center, or if your frame rate's really low, or if you make the user do a barrel roll when they're not doing it in their room, then like people will get ill. And you can try those experiments if you have friends that you don't really like, but I don't recommend you do it in a video game that you want to make money on. The next thing is that UI is tricky. So in a video game, there's a lot of games that try to contextualize their UI, but if you ever have a real serious UI problem, you can always throw up a button bar or an icon on the screen or a health display or something. There's always a simple solution to UI in a video game to some degree. That's not true anymore in VR because you don't have that ability to stick things to the user's face. If you glue an indicator or a health bar or something onto the user's headset, they're going to be really uncomfortable because it's going to feel like it's stuck to their head. Because in the virtual world it is, right? No matter where they look, that little bar is always in their view. And generally, that is not a comfortable experience for users. That means you're going to have to do a lot more work on your UI to make it contextual in a way that you might not have had to do with a game that you played on a monitor. So the next thing to know is that reality is not presence. So what does that mean? So presence is the sense when you put on a VR headset that the world that you're seeing in the headset is real and that you're in it. And in a really good VR experience, you can achieve presence. Like you can put on the headset and after seconds to minutes, depending on the experience and depending on the comfort level and how compelling it is, you may or may not achieve presence, but when you do, it's really amazing because you can kind of fully immerse yourself in whatever the developer has created for you to experience. But the note here is that realism is not required for that. So really low polygon scenes, really stylized rendering works great in VR, and you can totally believe in a world that has no textures. So in our early demos of the prototypes for our consumer versions, we showed a scene with very low 100 polygon animals with no texture maps hanging out around a low polygon fire with like a 3,000 polygon terrain and like a 200 polygon river, and it's totally believable. You're super happy to be hanging out with the little fox and the little rabbit, even though they're obviously not real animals. And last is you can leverage our user experience feedback. So like I said, the team that works in Oculus Publishing is here to talk to developers, and we are more than happy to try your games and give you feedback on what is working and what isn't working. That's both technical and that's design-based, because we've all shipped a lot of video games. We can tell you what we think, and you can go and do with it whatever you want. All right, so let's go through some of the VR design challenges and opportunities. So VR is basically uncharted territory when it comes to game design. Games have been made in VR before, but not in a broad and not in a highly successful way. So there are some design patterns from traditional games that work, but others that don't. Like running very fast in a first-person shooter is not a very good time. I'll go over why that is in a second, but there's things that you would do in a genre in a traditional screen game that don't work. The flip side of that is there are probably lots of new patterns that are just waiting to be discovered that are super exciting and super interesting for VR. So like locomotion solutions are one area. Like walking is generally not a good idea if you attach walking to a joystick, but teleporting works great, which is kind of a surprising result. It's not obvious that teleporting would be comfortable for users, but it turns out that it is. So for a designer, that's exciting because there's new things to learn. You can be the first person to create a fundamental part of the grammar of VR. It's exciting to figure out how to do a traditional game in VR, but more exciting is to figure out the new types of games that will be enabled by VR. So some existing game genres will work in VR, but I think that there will also be new genres that don't exist yet that will be created by VR. And the only way to find those is to explore, and developers like the people in this room are the ones that are going to find those new games and get to create them. Oculus is not going to do that. We can help you in that mission, but we're not going to be the one to create those new experiences. And like I said, the grammar for VR is not defined yet. It's super early. It's mostly borrowed from traditional games so far. but it's for you to invent. The same thing happened on mobile. Like early in the mobile game life cycle, there were a lot of games with twin thumbsticks where you'd rest both your thumbs on the game. But over time, people found ways to make native touch controls on mobile devices to make super fun experiences. Like you don't get an Angry Birds with dual stick controls. Iteration is how that happens. So you just keep trying new input methods and experiences and design techniques, and over time, the games will get better. Early games will get to define this grammar. So another good example is Halo. Like shooters existed before Halo, and other shooters had done joystick controls before, but Halo really nailed it in a way that transformed shooters for a really long time and opened up an entire genre. And I think that opportunity also exists in VR. So the next thing you know is that brains are really weird. We know a lot about how brains work and about brain hacks to get people to experience what we want them to, but we're still constantly surprised by experiments. So one of the fundamental tricks that you have to deal with in VR is the concept of vection, and that's the sense that your brain believes that it's moving. And you measure vection by a lot of different metrics, but two primary ones are the motion of your visual field, that is how the world around you is moving according to your eyes, and secondarily, well, not secondarily, but also by your inner ear sense. And your body has a mechanic where if you eat the wrong mushroom and you become poisoned, it'll change the chemistry, particularly in your inner ear, and your sense of balance will be thrown off. And what that does is it causes a mismatch between your sense of balance and your sense of motion from your inner ear and what you're seeing in the real world. And luckily for you, your body reacts to that with nausea and makes you throw up, gets the mushrooms out of there, and makes you sick. The bad news is VR can work that problem in the opposite way. So if you introduce motion in the user's visual field that their ear is not experiencing, they'll see that as a mismatch potentially. And that means that they might get nauseous, they'll think they're poisoned, and they'll get sick. You experience the same thing if you try and read a book in a car, if you're susceptible to that. You can trigger that on a user with VR. So you need to be careful with your designs. So our best practices covers that sort of stuff. Like if you only move the user's head in a way that's sort of one-to-one with the way their head is really moving, only reposition the camera when they reposition their head, then they'll have a comfortable experience definitely in a static environment. But you probably want to go beyond that. Lots of games want to have the users moving around. So you should break those rules. Like there are experiments to be done there. I mentioned teleporting works. There are other ways that people are going to figure out to do locomotion and solve other issues with user comfort that haven't been invented yet. But you need to test those challenges. And the trick with testing is that people vary wildly in their reaction to these experiences. So you need to test on tens of people. It's not enough to have like one or two friends that you think are susceptible in VR. People's triggers for comfort and discomfort vary wildly, and there's a lot of different triggers. I only mentioned two, the inner ear and your visual field, but there are others that you might mismatch and you might trigger on. So you need to have a lot of people that test your game before you can decide that your experience is really comfortable. And if you find that your experience is uncomfortable, don't cling to it. You need to use comfort as a primary test for your experience to measure whether your game is going to be successful. So what's up with hands? Hands are really weird. So all this design stuff gets even more interesting when you have your hands in VR, because we've never had high-quality hands in video games before. So what does that mean? We don't know. So I showed you one experience playing with toys. That's super cool. I promise if you make a game where people play with toys, they'll enjoy it. But that's not going to be all the games that have hands in VR. It's probably not Trespasser. If you've ever played Trespasser, it's probably not crudely stacking boxes to fight dinosaurs. But there's going to be a lot of awesome games that get made using hands, and we have no idea what they are. And to me, as a person that makes games, that's super exciting. So the message generally there is there's a huge new continent of design. We've just landed on it. We've explored the beach. We don't know what's in the woods. There are certainly monsters in there, but there's also treasure, so you should go out and try not to get eaten. Okay, so now I've talked about why design in VR is exciting and where we are in VR launch-wise, and so now what do you need to do to make your first VR app? So I'm going to go really quickly through the 0 to VR in 5 minutes, and I'm going to do that in Unity because it's what I am most familiar with building quick VR apps in. So what's needed for VR? Generally, when you're making a VR app, the thing that you're trying to do is rendering a scene at 90 frames a second for both eyes. You're doing it at 90 frames a second because that's approximately what we find the comfort bar is. You need to be rendering at that rate for the user to be comfortable. So that's what we designed the hardware to do. That's the refresh rate of the display. You need to do it twice because Most people have 2 eyes. Not all people, but most people have 2 eyes. And you need to do that consistently. If you start dropping frames, the world is going to stutter. And I promise you, if the room started running at a low frame rate right now, you'd be pretty unhappy. So it's easiest to achieve these things in off-the-shelf engines. So if you've got your own graphics engine, great. But Unity and Unreal both include built into their engines now support for the Oculus SDK, so you don't have to do very much work to get it started. So I'll show you that now. You do need a dev kit, so I'm going to cover an example that shows the DK2, but this also will work with very few modifications on the Gear VR. So if you haven't used Unity before, it's a broadly supported 3D engine. You do most of your scripting in C#. It has native support for VR, and that means that you don't need any plugins or extra software to make it happen. But there is software that we provide to make it a little easier. So the first step is download Unity. You get it at unity3d.com. Then you go to oculus.com and grab utilities for Unity. It's a package that you're going to import into Unity. And then while you wait for the downloads, make a Unity account, because you'll need it to boot the software. It's totally free to use, both of those. So the first thing you're going to do is make a new project. Then you're going to import the utilities for Unity's package that you downloaded from us. You're going to take the main camera and delete it. The main camera will work, but the one that we provide you gives you a few more features that you're going to want as you get more into VR. And the way you add our camera after you've deleted the existing camera is you drag it in from the prefabs folder. So if you browse through your assets directory, there'll be a camera prefab there. Drop it into your project. Go into the menu and create a game cube by selecting the Game Object 3D cube. And then in the little menu that pops up on the right, set the size to 1 and the Z position to 1. And then go into your project settings, player settings, and turn on virtual reality. It's literally a checkbox, and then hit play. Holy crap, there's a giant cube in front of you. It's huge. You just made an epic monolith, magic of presence. You're super excited now, and you're going to run out and make a video game. So it's actually, it will be surprising if you have not done all these steps before, just how exciting a really simple cube can be, because it's in the room with you now, and it wasn't there before, and you made it with about 10 clicks of the mouse. There are obviously other options to make VR. So I showed you how to do it in Unity on DK2, but VR support is also built into Unreal 4.9. In a similar number of clicks, you can get experience up and running there. If you are writing your own graphics code, we also have a native SDK that supports OpenGL and DirectX 10 and 11 on Windows. So that's the message. It's time to explore. There's a ton of stuff to figure out and make video games for, and a lot of exciting stuff is going to happen in the next year, and you can be a part of it. Thanks. All right, so we've got time for some questions. I answered all the questions. That's a good question. We don't have a policy decided yet on whether we'll ship serious stuff. Like, a lot of it will definitely be built for the Rift. I would expect you would see it in our store. Our focus so far has been on games, just because we think most of the people buying the early headsets are going to be gamers. But absolutely, there'll be a market for serious apps eventually. Yeah. Yeah. So glasses fit into the Rift. If you have super wide glasses, they will fit less well. The consumer version, if you've got a DK2, the consumer version fits a little better than the DK2. But yeah, they should generally fit, unless you have the like epic horn rims with like accents. Yeah, so the DK2 is a 75 hertz device. The consumer version is a 90 hertz device. And separately, the Gear VR is a 60 hertz device, so it's different per device. That's a great question. We haven't announced it yet. The things that we have announced are that the combined package for the headset plus the PC should come in under $1,500. And we've also announced a recommended spec that you could probably go build on Newegg, and then you could get a pretty good ballpark. It doesn't have a focal adjustment. It has an interaxial distance adjustment, though. Sorry, he asked if there was a focal adjustment on the consumer Rift. There's not, but there is an interaxial distance adjustment. Yeah, we announced it at Connect. I'm pretty sure the answer is that 1.0 will be in December, but I don't know if that's the final date, so you should look at the Oculus Connect announcements for the final answer on that. Sure. So the question is mobile VR or room scale VR more compelling? They're obviously very different. The Rift and other like larger tracking volume devices obviously provide like a more immersive, more high fidelity experience. But the advantage of the mobile devices is that like it doesn't quite fit in your pocket yet. I think it'll get there eventually, but you know it fits in a very small belt pouch, depending on your particular fashion sense, you know, like so it's a highly portable device that gets you what ends up being a really high quality VR experience anywhere you want. So obviously there's like a range of fidelity of experiences, and we have devices in sort of two spots in that curve. You can absolutely sell your games in other places, and we'll give you keys to sell your games on other stores that users can then activate in our store. Maybe. Like, we don't have a browser project at the moment. I'm sure someone is working on that right now. So yeah, we don't have it. It's probably not fundamentally more compelling to browse the web in VR than it is on your phone. But as resolutions increase, it will be more compelling, right? Because the need for monitors will be lessened by the resolution of your headset. Like, why have one monitor on your desktop when you could have 100 monitors wrapped all around you? Mm-hmm. Yeah, I'm not sure. That's a great question. Like, as I mentioned, it's an unexplored continent, so that sounds like an awesome experiment. If it's really successful that you get your phone in VR and everyone wants to see their phone in VR, I'm sure that it will happen. Yeah, I haven't tried it. So. Yeah, so on the SDK, we're gonna maintain support for the 1.0 SDK for a really long time. So we're not gonna like end of life the old SDKs, and we already support a pretty broad range of devices, right? Like we've got the DK2 supported in the latest SDK. The DK1 is a little less well supported, but all the way up through multiple prototypes and all of our engineering tests to the consumer version, and then I'll continue into new versions. And to some degree, the mobile and the PC SDK are compatible. It's like the at the engine integration level, you can build a game that targets both with very little work. Yeah, for sure. Like, so if you go get a DK2 now, we still sell them on the store, on our website, and you build an app against our current SDK, it will eventually work on the consumer device. You'll have to update the SDK to the 1.0 version to make sure it works with the SDK we launched the device with. But you can build an app for consumer launch with the DK2 and it'll still work. Getting a 90 hertz device before the launch of the Rift is trickier. So the publishing team manages that hardware and we give it out to developers. But like we have hundreds of those devices not tens of thousands like we did with the previous developer kit. So I would say if you're interested in VR, the best way to get started is to buy one of the existing available headsets, the Samsung Gear VR Innovator Edition or the DK2. You can build apps for that will work at launch. And if you have something super awesome and you think it's worthy of a headset, like send us your game. Let's start a conversation, and maybe we can work on it. Sure. So, I mean, Michael Abrash is in charge of our research department, and he talked a little bit at our trade show a few weeks ago, Connect, about the stuff that he's working on. And it's both to get your entire body into VR, to fully capture you and allow yourself to be in VR, but also to let you experience the virtual world fully across all 5+1 of your senses. So, you know, to some degree, you know, butt kicker devices might be part of that, but they are thinking, you know, very like blue sky, open field about what it will take to get all those things done. So there's open research into all that stuff. I have no idea what the answer is. Probably not. Yeah, I don't know the answer, but probably not. The what? Sure. Yep. It's not that it doesn't work. So some games show a body and some games don't. So not all games are first person, but the games that are first person and have you inhabiting a person in VR, some of them will show you a body. It's not that it doesn't work. It obviously works to some extent. The issues with it are that it's not your body. So if you like shake your leg, the avatar's leg is not going to shake. The feet might not be in the right position. It's also a little tricky because like you have a gender, the character has a gender. They may not match, and for some people that's a disturbing experience. If you, not everyone. I mean, some people are very interested in that, I'm sure, right? I mean, not even joking. But the body doesn't match yours, and so there's a lot of different reasons, both like animation-wise and perception-wise, why that might be a problem. That said, I've seen some pretty good, you know, bodies in VR. I've inhabited a low polygon robots and like sniper and like a lot of different bodies. It's not that it doesn't work. It's just that it's not easy to do. You need inverse kinematics, and you need a good model of where you think the body is going to be when the user is in a certain position. So. I haven't shipped any games for the Rift. I shipped a bunch of games before I came to Oculus. I worked on Oculus Medium for the first year or so that I was at Oculus. Sure, yeah. They're secret though. I mean, those are they're my babies that I have to work on at home. All right, thanks guys. I'll be around for a little while, and if you want to see the hardware, I've got a Gear VR and a prototype of the Rift here you can check out.